You know, Him, this is such unfortunate news what we're hearing from the Atlantic. All 5 passengers have been declared dead.
Right, absolutely. Now, the big question is what actually happened and if whether or not there were systems in place to prepare for such an eventuality.
Of course, talking about the missing submersible in the Atlantic Ocean, the search for OceanGate's Titan submersible has come to an unfortunate conclusion. The US Coast Guard said that the underwater craft, which was used for a voyage to the Titanic, or rather the wreckage of the Titanic, met with an implosion and was found in pieces. All 5 passengers on board have lost their lives. More in our next report.
On behalf of the United States Coast Guard and the entire Unified Command, I offer my deepest condolences to the families.
The massive international search for 5 people aboard a missing submersible in the North Atlantic came to a grim end on Thursday after an unmanned deep-sea robot discovered debris confirmed to be from the lost vessel near the century-old wreck of the Titanic. Here's U.S. Coast Guard Rear Admiral John Mauger.
An ROV, or remote-operated vehicle, from the vessel Horizon Arctic discovered the tail cone of the Titan submersible approximately 1,600 feet from the bow of the Titanic on the seafloor. The ROV subsequently found additional debris. In consultation with experts from within the Unified Command, the debris is consistent with the catastrophic loss of the pressure chamber.
Those who perished include British billionaire and explorer Hamish Harding, Pakistani-born business magnate Shahzada Dawood and his 19-year-old son Suleiman, French oceanographer Paul-Henri Nargeolet, and Stockton Rush, the American founder and chief executive of OceanGate Expeditions, the company behind the sub.
This was a incredibly complex case, and we're still working to develop the details for the timeline involved with this casualty.
The Titan had set off Sunday with 96 hours worth of oxygen, according to OceanGate, in what was expected to be a 2-hour dive to the Titanic. But upon its descent, the sub lost contact with its support ship. Rescue teams from several countries had spent days searching thousands of square miles of open seas with planes and ships for any sign of the 22-foot vessel. Hopes had been lifted when Canadian search planes using sonar buoys recorded undersea noises they described as banging sounds. But Mauger dismissed the idea that the noises came from the Titan.
There doesn't appear to be any connection between the noises and the location on the seafloor. Again, this was a catastrophic implosion of the vessel, which would have generated a significant broadband sound down there that the sonar buoys would have picked up.
Chris Brown, a friend of victim Hamish Harding, said he bowed out of the adventure due to safety concerns.
Parts of the submarine that I'd seen in the testing in the Bahamas just seemed a bit shoddy. They're using industrial piping for ballast. They're using an Xbox controller for the steering. They flatly refused to get any form of certification.
Questions about the Titan's safety were raised in 2018 during a symposium of submersible industry experts and in a lawsuit filed by OceanGate's former head of marine operations, which was settled later that year. OceanGate Expeditions said in a statement, "Our hearts are with these 5 souls and every member of their families during this tragic time."
Now for more on this, we're now being joined live from Washington, D.C. by Professor James Bellingham, a renowned marine biologist. Sir, welcome back to the broadcast with us.
Thank you. It's a pleasure to be with you, although I wish we were under better circumstances.
Absolutely, sir. Now, we discussed this yesterday as well, and an implosion is something that you had taken us through. Now, just for better understanding here, what is an implosion and what could have caused it?
Well, what happens when you descend into the ocean inside a pressure vessel is the water that you descend through is building up pressure around you as you get deeper and deeper. So for approximately every 10 meters you descend into the ocean, you develop another level of pressure equivalent to the what we would call 1 atmosphere, the pressure of atmosphere at sea level. So by the time you reach a depth of 3,800 meters, you are surrounded by this pressure of 380 atmospheres, which is approximately 5,400 pounds per square inch. So that's a very large amount of pressure pushing in on that pressure vessel at any given point. And so pressure vessels are designed to be very spherical and cylindrical in order to distribute all of those stresses evenly through the material of the pressure vessel. And that's how they succeed in retaining their integrity down to great depths.
Professor, now this is, we believe this is not the first time that this submersible was used for a deep sea investigation or any kind of visit to the wreckage of the Titanic. What went wrong this time, and was there something to do with the material that is used to build it, like carbon fiber and titanium hull is what we researched and found out, and there are comments on the fact that this material should not have been used for a submarine used for these kind of purposes. So what happened, what went wrong this time?
Well, so this vehicle had a cylindrical midsection, which was made of carbon fiber composite. And then it had end bells, these spherical end bells, or hemispherical end bells that were made of titanium. And in fact, the forward titanium end bell had a viewport built into it, that large viewport that you see in the pictures of the submersible. So there's a series of challenges associated with using these various materials together. So titanium is extensively used in the deep sea environment, and vehicles which go much deeper in the ocean than this vehicle was rated for. This vehicle was rated for 4,000 meters, just a few hundred meters deeper than the depth at which the Titanic lies. So titanium is a well understood material for building pressure vessels and for use in the ocean. The carbon fiber composite is a bit of a different, a more unusual material to use in the ocean. There's a couple of challenges with it. One of the challenges has to do with the fact that carbon fiber, even in composite form, tends to work much better under internal pressure. So if you were to use it for a scuba tank where you tried to put a lot of it, so you had a high pressure on the inside rather than the outside. On the outside, when you have pressure on the outside, you have to make it thicker. Now, it's still a lighter material than titanium, which is why they used it. It allows you to carry more payload into the ocean. And so for them, that was a critical thing since they wanted to be able to carry 5 passengers. One of the big challenges with any material that you're going to use, whether it's in a submarine or an airplane, any place where the strength is really critical, is you have to worry about its characteristics, not just for that first test when you put it in a pressure vessel or you go to the test depth that it's designed for in the ocean, but you have to worry about how that particular part of the vehicle is going to deteriorate with time as you encounter the rough and tumble of operations in sea, perhaps in rough ocean conditions, perhaps it get banged against the side of the hull at some point. And in general, in the general wear and tear of being exposed to the sea air.
Right.
So I beg your pardon?
Right, Professor. Yeah. Professor Bellingham, well, thank you so much for joining us on this broadcast yet again with your inputs on this.
You're very welcome.